Welcome to this tutorial about the factory method pattern. In this tutorial we're going to be looking into what the factory method pattern is. It's one of the patterns of the gang of four. So first off, let's try to see what the pattern actually looks like. So I'll start by putting some classes here. So the whole idea behind the factory method pattern is actually that we want to be able to control who instantiates classes. So we actually create a class that will instantiate subclasses. So that means that instead of using the new keyword directly, we can use something like a string for creating classes, or we can use an enum or whatever we want. But the general idea is to decouple the instantiation, and I'll show in a second why this is useful. First off, in this first video, I'm just going to discuss the general factory method pattern. So first off, we have a factory class, which is kind of the starting point for the factory. So let's call this factory. And the factory then creates instances of certain objects, which can be this can be some concrete one. Let's call this class concrete 1. And let's not do that one. Let's duplicate that. Concrete 2. So the factory will instantiate these classes. Oftentimes we want to do this indirectly, so we will have some kind of interface in common between these concrete classes. So oftentimes we'll put an interface in between here, so we would call that concrete or something like that. Can also be an abstract class, some kind of abstraction. So what the factory does is it has a method here saying I want to create for example, one of these. So the client out here using the factory, whatever application you've been creating, is going to invoke some it's going to invoke a method on the factory saying create concrete 1, and it's going to use something like a string or something like that for that. This means that now the client doesn't need to know about the concrete implementations of this class, and it doesn't need to know about concrete class number 2 as well, because the factory will actually create everything and return that to the client. And I think it's much easier to see if we code this. So let's try to code it. So we'll go to NetBeans and create a new project in here, just a normal Java application, and let's call this factory method, and finish. Just a simple console application for this case. So we'll start out creating something like, let's create a new package in here, and let's call this package something like factory, because this is going to hold the factory itself. And you'll also see why it's smart to have a package for this, because we will be able to use that later. So first off, let's try to do a program without actually using the pattern, so that we see how we can actually utilize this pattern. So in this case, as usual, I'm going to use some weird example here. I'm going to create a very simple role-playing game in the console where we have some players that can attack each other, and what we're going to use the factory method is we're going to create a factory that can create weapons, and I'll show that later. But right now let's just go for just open Paint. So I'll show you. So in this game here, I will have something like a player, this guy here, and this guy is, let's call him player. And this guy player here will have some kind of weapon. So he can have, like, this is a sword, and he can have something like a mace as well. This is a mace, and also he can have something like a staff, you know, for a magician or something like that, for a wizard or something. So we have the sword, we have the mace, and we have a staff. So now we have these three different things. So the problem is that when we also have a game here. So the problem is that when the game usually will create these different types of weapons. So early on in the game you'll get lousy weapons, later on in the game you'll get beautiful, really good weapons. All of these guys here, we can call them weapons. Right? So they will all inherit from some class weapon or use an interface called weapon because they're all the same, they have some of the same attributes. And the player will be able to have multiple players. We can say that in this game, the game will hold some players. Let's just make this into classes. And the game will also be holding some different weapons that it can actually put onto the player. And the player will also be relevant for the weapon because the player will also aggregate a weapon. In other words, the player will have one weapon here. So player will have one weapon, and a weapon can only be at one player at a time. And so a weapon can also only be in one game at a time, but the game can have 0 or many weapons inside of it. Let's make this into a class as well. Okay, so this is it. So how many players can there be in the game? I would say there can be 0 players or maybe many players. And also I think the players should be able to play against themselves. We'll look into that later. Okay, so we have a game, we have a player, and we have some different weapons, and we might have multiple players because we see there's multiplicity here, there's multiplicity here. So we can see that game will need something like a list of weapons and a list of players, whereas the weapon will be connected to some game, and the player will also need to have one weapon, so we can just use simple member variable for that. But let's just try to implement that real quick. So I'll go back here to my main application, and I'll start creating some classes in here. So let's start out creating the player, and we wanted to create a game. We wanted to create some weapons. Do a class here. Weapon. We wanted to create some different kinds of weapons. So let's go for a mace and a sword and the staff as well. So everyone is happy. So now we have a staff and a sword and a weapon. And the mace, of course. So the mace and the staff and the sword, they should all, of course, somehow inherit from the weapon. So what I'm thinking here is that the weapon itself needs to have something like, needs to be aware of something like physical and magical damage. So if I go back to Paint here, we can see that we have different players, but I'm also thinking that this player here can have either, he can have some, he can be physical, or he can be magical or something like that. So also, I think he should have something like a physical shield and a magical shield. So that, for example, if I create a wizard, he will have better magical shield than physical shield, and if I create a barbarian or something, he will have better physical shield. Something like that. And the same for the weapons. So for example, the staff will only have magic damage, whereas the sword will only have physical damage, and the mace will have both. So this is what I want to implement. Okay, so let's try to go back. So we need to have something like double magic damage. So magic damage will be how much magic damage is this weapon going to do, and also physical damage. How much physical damage will this weapon do? I want this to be shared with all the subclasses. I want to create sword and staff and mace needs to be subclasses of this, but I don't want these to be publicly available so that all other classes can mess with the internals of this class. So the problem is if I make this private and I inherit this subclasses won't be able to use it. So I actually want to do this in the subclass. For example, this is what I'm going to do. I'm going to say that when you're using a mace, the magic damage of a mace, the mace will only be able to utilize like 25% of that and only 85% of the physical damage. So I want to handle that differently based on whether it being a mace or a staff or whatever. So if we go back to our, so I'm going to say that for the mace, it's going to be utilizing 85% of the physical damage and only like 25% of the magic damage that it gets. And the staff is normal 100%. I think the sword is going to be like 105% the physical damage or something. So we're going to modify it dependent on which weapon it's going to be. So if I make these private, I won't be able to inherit them. So what I'm going to do instead, I'm going to make them protected. So this means that subclasses will be able to use them. And unfortunately, also other classes that are in the same package here. So what I'm going to do, I'm just going to move them, the weapon, the staff, the mace, and the sword. Just for now, I'm going to move it into this factory here. I know it's not a factory yet, but let's just move them. That's it. So that's it for now. Now we have the weapon. Maybe I would want that no matter which weapon you have, I also want these values to be available. So what I'm going to do, I'm going to use some getters for this. So I'm going to say public double get magic damage. But actually I don't want to implement this here because, as I just told you, for the staff I want the magical damage to be 100%, and I don't want that to do physical damage. But for the mace, the magical damage should be 25%. So it needs to be different dependent on the weapon. So I cannot put it directly in the weapon class because it's different for staff and everything. So what I'm going to do is I'm going to make this abstract, thus forcing the subclasses to implement that. And I want to do the same for physical damage. So I'm going to have one called get physical damage, like that. And in order for this to be abstract, of course I need to make the class abstract. And this also means that I cannot instantiate weapon as a class itself, so I cannot write new weapon now, which also makes sense to me because if we look at my drawing here, we can see that weapon is abstract. It's a class, it's something that I figure out in my head here, but it's not really something from the game. So we see, if we want to look at what is actually in the game, we have the guy here, he's in the game, he's really in the game, so player is actually something in the game. Also the sword is something real in the game, the mace is something real in the game, and the staff is something real. But the other things, like the game itself, it's not something that we actually see. The player, we see him, but weapon class we don't see that, but its implementations like the sword and mace and staff, we actually see those in the game. So these are concrete. So it wouldn't make any sense for me if I wanted to create a concrete weapon, because what is a weapon? So yeah, so that's why it should be abstract. If I then go into the other classes and force them to actually implement this, so let's do the hard one first. So I go into the maze first, and I'm going to say that this actually extends the weapon class. Then I get an error saying I should implement all the abstract methods. So I click that. So now I know if I want to do any weapons in here, I should be able to return their magical damage and their physical damage. Okay. So fortunately, I know that I already have from my weapon class, I have this one magical damage, which should represent the magical damage. So let's put that here. So I could just return this. But I had one more requirement, and that was that I actually wanted to return for magical damage only 25%. You see down here, 25% of the damage should be returned. So I multiply by 0.25, and then I should be done. I can do the same for the physical part, just like that. So, and that should be 85. So now I implemented that mace is kind of a special, it's an amazing weapon. It can actually return only 25% of magical damage and 85% of physical damage. But if we combine these two, it can be quite powerful if it's the right weapon. So it's kind of the reason why I needed a class for this is because I want to do special calculation based on the type of weapon I'm using. So this was the mace, but I have one unsolved problem here, and that unsolved problem is that right now inside my weapon these are not initialized, so I can't be sure that magic damage and physical damage will be initialized. So I need somehow to initialize these two values. So what I can do is I can actually say whenever we create a weapon, I want to have both magical and physical damage. So I could create something like a constructor like this and say this is what the constructor looks like, and I want, then it means that if I save this, I can see that all the subclasses, for example mace here, would need to implement that constructor as well. And this would actually make sense for the maze, but maybe not for the other ones. So let's try to go for the staff and also say that this extends weapon, and then we need to implement these both like that, also the constructor. Okay. So I would say that if you construct a staff, you wouldn't actually supply the physical damage thing because it never has physical damage. So what I actually want, I want to have a method in here just like this one, but without the physical part, because I'm not going to use that. And actually physical damage, instead of doing this, I want to say physical damage should just be 0 when I do it like this. And I don't want this this one here. So I'm not quite sure if we should just leave it here. I think for now let's just leave it here because I think it will be easier to understand the rest. So we'll just do it like this. So this means we can either create a staff with both of them, or we can just leave out the physical damage, which we would probably do in most cases. Same thing is true for the sword, but let's just do this first. So I said that if I look here, I said that the staff should return 100% of the actual magic damage. So I'll just say return magic damage. Okay. So for the physical one, I can also return that, because the physical damage should just be 0 by default if it's not set. Because I'm setting it to 0 here, this constructor will ensure that it's set to 0 when I construct it without the physical damage. So it should be 0 if someone constructed it and put physical damage on the staff. It would actually just be set like normal. Last one, the sword. Extends weapon. And then I need to implement the abstract methods and constructors. Okay, so that's it. So the magic damage should just return magic damage, return magic damage. And the physical damage should be special because, again, I said that for the sword it should actually add 5% to the damage. So instead of 105 here, it's going to, instead of 100%, it's going to be 105%. So in order to do that, I will say return physical damage multiplied by 1.05. This means it will add 5% because this is just an amazing sword. Later on, we could add to this, we could save this like a multiplier or something on the weapon, and then add to this multiplier as the game progresses. But I think for the scope of this tutorial here, this is probably too much. Okay. So that's it. So now we have the ability to actually create our weapons. So before I start creating the player, I just want to have a method here. So let's start creating the game. So I'm going to say public void start. So this is just the starting point of the game. And I'm going to show you why the factory method pattern is powerful, or what the problem is here. So if we look at our drawing here, we can see that the game is dependent on the weapon, which makes sense because the game has to know about the weapons that is inside of the game here. It will need to know that. It also needs to know about the players. What the game shouldn't know about is the actual implementation down here. This is implementation. Wow, that's a bad color. Let's use purple. This is the actual implementation of the weapons, and I don't think there's no reason why games should know about how to instantiate swords and maces and staffs. It should just use the interface up here. But let's look at it from the code. So now I want to instantiate, I want to put weapons in the game. So I want to create some weapons and put them in a list. So let's create a list of weapon. I call that weapons. I just probably need to import this first. Weapon. And I need to import Java util list. And I'm going to create that as a new array list. Wow, that's the wrong one. Sorry. New array list. And I need to import that as well. So now I have a list of weapons that is empty. So if I want to add a weapon to that, let's say I want to add a staff. So how would I go about creating a new weapon? So if I say weapon W equals new weapon, I get this weird thing. So let's just skip that for now. So if I do something like this and I say I set the physical and magic damage, I get an error. And this error is saying weapon is abstract, and this is what I talked about before, that weapon is something abstract. We can't create a weapon. It needs to be either a sword or a mace or a staff. So now we have a problem here, because I don't want the game to know about the sword and mace and staff. So I don't want to do something like that. So if I want to put weapons in here, I would have to do something like staff s equals new staff, right? And then I would need to specify the magic damage for the staff. Let's say it's 45. And then I can say weapons add, and then I can add the weapon. So why is this problematic? The problem with this is that we do not want the coupling going from game here to the staff itself. This is a no-go for us. We don't want this stuff here, because we will couple game directly to the implementation of the different weapons. We only want game to be able to see the interface. So how do we actually solve this problem? How can we create weapons if we don't know how to create them? That is actually what the factory pattern is. So instead of game using weapons directly, we introduce something new here, which is called a factory. And we say factory is now the one in control. So game uses factory to actually create the different weapons, and the factory will know about the weapon, and factory will also know about all the implementations. So now instead of having the game itself up here, instead of the game knowing about this, we move the problem to a factory, which we will put together with the weapon class, the sword class, the mace staff, and the staff class in a one single package. Let me just draw a package around here. So this guy here will be put in a special factory package. Wow. Okay. So now all this is cohesive. We have this guy here in one package, and we can just use game for the factories. And this is the point of the next tutorial. I'll show you how can we refactor. So instead of creating the stuff like this, we can actually just create them through a factory, and game doesn't need to know anything about the implementations. So that's it for the next part. Thank you for watching this one. See you in the next part.